Welcome to Maths and Science by IITIAN channel. In this channel, I will be taking up in this lecture exponential functions. I have given the brief of exponential functions in my previous lecture. It is the lecture number 14 in the course of calculus. We are going in detail of each and every function. And here in this lecture, we will be talking about exponential function and we will be taking up a very good example to prove that e to the power of z is equal to limit n tends to infinity 1 plus z by n to the power of n. This value is very important for the benefit of Maths Olympiad, JEE Mains, JEE Advanced and CSIR mathematics aspirants and all the mathematics enthusiasts. The value of E can be expressed in different forms. It is one of the forms. In limits, we can express the value of e to the power of z. It will be valid even for complex numbers, real numbers and all the numbers. If z is equal to 1, it will become simply limit n tends to infinity 1 plus 1 by n to the power of n is equal to e. In the last class, expressing e in terms of hyperbolic functions we have seen. Now, in this, we will see expressing e to the power of z in terms of limits of an exponential function. This can be achieved in two ways. One is binomial function method, expansion method rather, and another is by taking the logarithms. I will be going with the system of using the logarithms, natural logarithms, and I will be proving this. Binomial expansion also is very easy. Let us apply this logarithmic method, which will be more effective. Both the methods are good. You can apply any method. I will give the hint at the end of this lecture after completing this proof with the help of logarithmic function and properties. Regarding binomial expansion method, I will give the hint so that you can do it on your own. Let us move to the problem. See this video till the end. You will get the real concepts about logarithms and how to use them and how to use the limit and how to get the value of e to the power of z rather. Here question is prove e to the power of z is equal to limit n tends to infinity 1 plus z by n to the power of n. This is what is required to be proved. Now let's go for the solution using logarithmic method. It's a very good method. Try to understand the concepts. What is here it is what we have to prove. E to the power of z is equal to limit n tends to infinity 1 plus z by n to the power of n. Let us take right hand side is equal to limit n tends to infinity 1 plus z by n to the power of n. Let this value, let us not call it as e to the power of z, let this value, let us say, sum m. Let us say this is value sum m and let 1 plus z by n to the power of n is equal to some L. Let us say, only we are arbitrary, L and M are arbitrary. Now, what we have to prove? We have got limit n tends to infinity, L is equal to M. We have to prove that M is equal to e to the power of z. We have to prove that. Now, for proving that, we have to find out what is the value of L. L is 1 plus z by n to the power of n. Taking logarithm on both sides, taking natural log on both sides, what happens? Ln of L, logarithm of L, natural logarithm of L is equal to L into n into ln of 1 plus z by n. Do you agree? And we know from the Taylor expansion, I have explained regarding the Taylor expansion in my previous lectures in this course. Please refer to that. As per Taylor expansion, ln 1 plus this z by n, let me say this is equal to some x. Ln 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x to the power of 4 by 4 plus, for absolute x is less than 1. This is the definition of ln 1 plus x. Please remember this. This is the Taylor expansion. For regarding the Taylor expansion, please refer to my earlier lectures. Now, let x is equal to z by n. Then, what happens? Ln 1 plus z by n. Replace x by z by n. What will be its value? Z by n minus z by n whole square by 2 plus z by n whole cube by 3 and so on. For z by n less than 1. Now, because x less than 1. Now, we will replace this value in this equation. Ln L is equal to natural logarithm of capital L is equal to n into ln 1 plus z by n, that will be equal to n into z by n minus z by n whole square by 2 plus z by n whole cube by 3 minus this, provided z by n is less than 1. Now, this will be equal to z minus z square by 2n plus z cube by 3n square minus, provided z by n is less than 1. Now we will take the limit. By taking the limit ln L n tends to infinity. If n tends to infinity in this equation, what happens? Z minus z square by 2 into infinity plus z cube by 3 into infinity square minus and so on. Provided z by n is less than 1. This becomes z, because it is independent of n, whether it is whatever value of n, the z will remain z, and for infinity this will be 0, this will be 0, and so on. For z by n is less than 1. That implies limit ln L n tends to infinity is equal to z. By expanding by natural logarithm properties, log a ln a is equal to b means e to the power of b is equal to a. We know from the properties of natural logarithm, if ln a is equal to b, it implies a is equal to e to the power of b. Please remember this. From this, limit n tends to infinity, ln L is equal to z implies limit n tends to infinity, L is equal to e to the power of z. What is that L we have assumed? L is equal to assumed as 1 plus z by n to the power of n. That implies limit n tends to infinity, 1 plus z by n to the power of n is equal to e to the power of z, because we have assumed L is equal to 1 plus z by n to the power of n. Hence, limit n tends to infinity, 1 plus z by n to the power of n is equal to e to the power of z proved. If z is equal to 1, it implies limit n tends to infinity, 1 plus 1 by n to the power of n is equal to e. Very important information about the value of e. This is about using the logarithms, natural logarithms, and proving the theorem. The next step for you, kindly use as a homework, use binomial theorem. Here we have used logarithms and also Taylor series. Use binomial theorem to prove above. How to use the binomial theorem? Binomial theorem is one plus z by n to the power of n can be written as sigma k is equal to 0 to n z to the power of k into 1 by k factorial into factorial n by n minus k factorial into n to the power of k. You all might have done in your elementary classes up to 10th grade binomial theorem. Please use this binomial theorem and prove this. About. If you have any doubts, please refer to me in the commentary or in comments. I will clarify your doubt. With this, I want to conclude this lecture, and if there is a value addition because of this lecture to you, kindly hype this lecture, share this lecture, and subscribe to my channel Maths and Science by IITian. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. And if you have any doubt, please comment. I will clarify the doubt. There are two methods to prove it. Simple methods, but the proof is important and the formula is important. And in the next class, I will be taking up different definitions for E. Different expressions for E. That we will be taking up. With that, we will be completing the logarithmic functions. Best of luck to everybody. Thank you for listening to me.